vast industrial workforce, only a small percentage of selected workers enter vessels or other confined spaces to perform periodic repair, inspection, or maintenance tasks. Yet safety professionals estimate that millions of workers in North America alone are exposed to hazards in confined spaces each year. You must never underestimate these hazards if you work in and around confined spaces. This program identifies some common hazards of confined space or vessel entry. It outlines requirements and procedures for safely entering and working in confined spaces and details the safety responsibilities of workers, contractors, supervisors, and work monitors for preventing personal injury. In this program, you will learn about confined spaces, how they are evaluated and classified, safe work permits, and how to prepare for confined space entry. In industry, a confined space is a certain kind of hazardous area that has 4 features. First, it isn't meant to be continuously occupied by workers. Second, it has limited openings for entry and exit, or objects inside it that could get in the way during evacuation or rescue operations. Third, it has poor natural ventilation. Fourth, its size, shape, or use may cause unacceptable air quality, a risk of physical engulfment or other possible injuries to workers entering it. Almost any enclosed space that is dangerous to humans because of heat, toxic vapors, low oxygen levels, or mechanical moving parts may be considered a confined space. This typically includes all chemical reactor vessels, tank trucks or rail cars, ship compartments, storage tanks, mixing vats, bins, silos, sumps, pits, boilers, sewers, pipelines, tunnels, ducts, or vaults. Work-related incidents in confined spaces usually result in serious injury or death. The 2 greatest dangers are suffocation from hazardous atmosphere and burns from explosion or fire. In one study, 80 incidents involving hazardous atmosphere resulted in 72 injuries and 78 deaths, while 38 incidents involving fire or explosion caused 69 injuries and 47 deaths. These tragic losses could have been avoided if the workers involved had understood the possible hazards and followed approved safety rules and procedures. One important way to prevent serious accidents is to identify all confined spaces that could present a hazard to workers. The physical construction, location, present contents, and past usage of each confined space should be evaluated by a trained individual to answer the following 3 questions. Could the atmospheric conditions inside the confined space or in the surrounding area cause any possible threat of death, injury, illness, or disablement to a worker? Is there a risk of physical engulfment by bulk materials? That is, could a worker be smothered by solid particles such as sand or grain, or be drowned in liquids such as chemicals, water, or even beer? Finally, are there any other physical or special hazards? For example, is there danger from electrical shock, radiation, temperature extremes, or machinery such as impeller blades, agitators, and grinders? All confined spaces should be thought of as potentially dangerous and must be periodically reevaluated, especially if there is a change in their usage or contents. Any confined space that is immediately dangerous to life and health, or that otherwise threatens worker safety, is classified by the employer as a permit entry space. A list of permit entry spaces is made available to all employees, and they should be instructed that no one is to enter these spaces without permission.
We were at the end of our shift when Jerry dropped a wrench down into an empty reactor we were working on. And he just looked up at me and said, "I'm not about to get suited up and go into overtime to pick up a wrench." He was going to hold his breath get down, and then right back out right away. Well, he got to the wrench, picked it up, but he never made it to the ladder. He had passed out. I called down to him, but he didn't answer back. It was hard to leave him, but we had to assemble the emergency rescue team. But by the time they got him out, I took one look at him and knew that that was it. It just doesn't seem fair. We had worked together like 8 years in maintenance. They left a wife and a daughter, a little baby boy. No one can replace a man's life.
Before planning any work in a confined space, one more question must be asked. Is it really necessary for a worker to enter the space? Or could the required maintenance or repair be done from the outside? Obviously, the safest course of action is to avoid entering any vessel at all, if possible. But when there is no other choice, the responsible supervisor or other qualified person must authorize a written entry permit, also called a safe work permit. Approved procedures for working safely are especially important in potentially hazardous areas such as confined spaces. A company's entry permit system establishes a set of written work procedures that describe how each job in a confined space will be done. A safe work or entry permit is always used when performing hot work, that is welding, brazing, or cutting operations that can change the atmospheric conditions in a confined space and create additional hazards. When completely filled out, the permit becomes a written approval for the work and guarantees that all possible hazards have been evaluated and all necessary precautions have been taken to ensure worker safety. Before any worker enters a permit entry space, a copy of the completed written permit is posted at the job site. The permit form has blocks for checking all required actions, similar to the pre-flight checklist used by airline pilots. No matter how experienced a pilot may be, he is still required by law to use the checklist so that nothing is left to chance. In the same way, the entry permit ensures that the most experienced worker or supervisor will never overlook some simple step that could result in a tragic accident. Entry permits may take many forms. They will always include the results of pre-entry atmospheric testing and the signature of the person authorizing the work. There may be mandatory requirements for communications, observers, and rescue teams, as well as for continuous atmospheric monitoring and ventilation of the workspace. A typical permit contains the following sections. The permit heading includes several standard items of information. If you're directed to prepare a safe work permit for a particular job, first enter the date and location of the work to be performed, the time of permit issue, and the time the permit will expire. A permit is usually limited to one shift, though you may be allowed to extend it until the job is done. Keep in mind, however, that any interruption of the job or any change of conditions in the job or work area will cause you to reevaluate any possible hazards and may require a new permit to be issued. Next, record the names of all workers who will be entering the vessel or confined space during the shift, plus the names of any work monitors or fire watch personnel, depending on the type of job. There is also a space for you to write a brief description of the job to be done or the particular procedures to be used. Entry permits must be approved by the supervisor of the operating area where the work is done, or by the supervisor who has direct control of the work crew during the job. In some situations, such as where a single individual is at a remote location checking manholes, that individual may be designated as a qualified person and allowed to authorize permit entry of a confined space. One important way to ensure the safety of workers in a confined space is by continuous inspection of the area before, during, and after work. The area supervisor inspects the work site under his control to make certain that conditions are safe for approval of the permit. The work crew supervisor makes sure that the workers do their job in a safe manner, that they leave the area in a safe condition. If operating difficulties occur at any time during the work period covered by the permit, the responsible individual will immediately revoke the permit. A permit must also be revoked to prevent any violation of approved procedures or any unsafe act or condition. For example, if a combustible gas or contaminant in the confined workspace should meet or exceed allowable levels, work must be discontinued and appropriate corrective action taken. When all hazards and their causes have been identified and eliminated, a new permit may be issued and work operations may be resumed under normal permit procedures. Because it poses such a high degree of risk to workers, entering any confined space requires extra care and preparation. This block of the permit is used to record any special training required for each particular job. In addition, periodic training on general entry and rescue procedures may be noted in this block. Finally, a pre-entry briefing should be held before allowing any worker to enter a permit entry space. This briefing is a conference between employees and a knowledgeable person who is familiar with the particular hazards and safety procedures for that job. Outside contractors performing work in a permit entry space must abide by all provisions of the written safe work permit. The company employee who authorized the permit will brief the contractor's employees about any potential fire, explosion, health, or other safety hazards in the confined space. He will also inform the contractor of safety rules and emergency rescue plans and spot check area safety during the work in progress. When the natural lighting in a confined space is not good enough to work by, auxiliary or additional lighting equipment may be used. Such equipment is required by law to be intrinsically safe. That is, it must be specially designed so that it cannot spark and cause an explosion. If auxiliary lighting is used, workers should also have portable light sources such as flashlights or electric lanterns close at hand so they will have enough light to evacuate the confined space in case of emergency. All additional lighting requirements are recorded on the permit form. This block reminds you to think about the nature of the job and its work conditions to decide if any special tools are needed. For example, only approved low-voltage electrical tools that are intrinsically safe may be used when the atmosphere in the confined space could contain flammable vapors. If you will be working in this type of environment, all electrical circuits should be equipped with a ground fault interrupter to prevent accidental sparking. Telephones and other electrical equipment must be of an approved non-sparking design. All tools and power cords must be visually inspected before use to avoid frayed insulation or broken wires. Special equipment also includes any mechanical ventilators, lockout devices, and padlocks used to prepare the confined space for safe entry. If the confined space to be entered is a chemical reactor, storage tank, or other similar vessel, there are 4 main steps in preparing it for safe entry and work. These are isolation, lockout, tagout, cleaning, and ventilation. Check the appropriate block on the permit form as you complete each step. First, isolate the vessel from the surrounding work area with signs or barriers as needed. For worker safety, post a sign at each entrance to let others know that workers are inside the vessel. Put up personnel barriers to prevent all other employees from entering the work area. For hot work, you may need to hang tarps to protect nearby machinery and workers from welding sparks. Most important, disconnect all steam lines or other process lines entering the vessel to prevent injury, physical engulfment, or the release of toxic chemicals. Remember, just closing the valves is not enough. All lines should be separated and capped off with line blinds or blank flanges. Be sure to locate blinds by tagging and remove them before starting operations again, or damage may result. Second, follow all required lockout and tagout procedures to prevent the movement of mechanical or electrical devices leading to the vessel, such as pumps and conveyors. The mechanical linkage that transmits movement to the machinery inside the vessel must be either decoupled or blocked to prevent movement. Third, empty the vessel and clean it thoroughly to remove any residue or hazardous materials. Depending on their previous contents, some vessels may be adequately cleaned by flushing them out with water. In other cases, the residue must first be neutralized with a chemical reagent and the vessel scrubbed with soap and water or steam cleaned. Keep in mind that even this procedure does not guarantee total safety, since chemicals embedded in vessel walls can oxidize or boil off during the work, such as when heated during welding. This is one reason that hot work in confined spaces requires constant, continuous monitoring for contaminants in the atmosphere. Fourth, ventilate the vessel both before and during the work period, and check it by periodic or continuous atmospheric monitoring. When natural drafts are not adequate, you must use fans, portavents, or other air movers to provide positive ventilation. Unacceptable air quality in a confined space is usually caused by contaminants in the work area and poor ventilation that allows toxic or poisonous vapors to collect. But be careful. Sometimes, even when no contamination is present, there just isn't enough oxygen in the confined space to keep you alive. You must test for safe atmosphere both before and during entry into any confined area using appropriate test equipment. To ensure continued safe work conditions, all environmental atmosphere testing devices or equipment should be checked and recalibrated periodically according to the manufacturer's specifications. You're required to test each enclosed space for 3 atmospheric conditions: oxygen content, flammability, and toxicity. Because of the extreme danger of suffocation in confined spaces, constant, continuous oxygen monitoring is required throughout each work period. To measure oxygen content before and during work, use a portable instrument that analyzes directly for oxygen and is not affected by any other solvent vapors present in the air. Oxygen content must be at least 19.5% in the confined space, measured at all levels. If the atmosphere in the work area is oxygen deficient, that is, the oxygen content is less than 19.5%, wear a supplied air respirator or provide adequate ventilation to raise the oxygen content to a safe level. But never use pure oxygen for ventilation, because an oxygen-rich atmosphere can be even more dangerous to workers. Welding or other hot work in a confined space with an oxygen content above 23% can cause explosions or vigorous burning of flammable materials, including your hair or clothing. This is one reason that, with the exception of small emergency oxygen tanks attached to a supplied air respirator, you must never allow any pressurized gas cylinders to be brought into a confined space, since an accidental failure of the pressure valve might flood the space with pure oxygen, acetylene, or other dangerous concentration of gas. After you've determined oxygen content, use a combustible gas indicator to measure flammability at all levels of the confined space. The reason for checking oxygen first is that if oxygen levels are too low, flammability meters will not function correctly. As a result, a confined space might appear safe, when in fact it would need only a small amount of additional oxygen to become fatally explosive. Flammability is measured in terms of the lower flammable limit, LFL, or lower explosive limit, LEL. This is the smallest concentration of a combustible gas in air that will explode when it contacts a spark or open flame. The concentration of any combustible gas must be 20% of the lower explosive limit or less, depending on the particular industry standard. Pre-entry readings above 20% LEL require ventilation to reduce gas concentrations to acceptable levels. If the combustible gas level begins to rise during the work in progress, you should stop all activities until the causes are identified and eliminated. If meter readings reach 20% LEL, work operation should be discontinued, welding equipment shut off, hot spots cooled down with a CO2 portable fire extinguisher, and the area immediately evacuated. Even if a gas is non-explosive at 20% LEL or below, it may still be poisonous in that concentration. Before entering a confined space, you must test the atmosphere for any toxic concentration of vapors. If the prior contents of the vessel are known, use the appropriate detector, analyzer, or meter to determine the remaining concentrations of those materials. Environments known to contain a toxic contaminant must be monitored for that contaminant and the results documented on the permit before work may begin. Toxicity is measured in terms of the threshold limit value, or TLV. When the concentration is above the TLV, you must either wear a respirator or reduce the concentration to below the TLV by ventilating the work area. When ventilation is used instead of respiratory protection, additional measurements must be made throughout the work period and recorded on the permit. Be sure to take readings at every level of the confined space, since toxic concentrations may be lighter or heavier than air, and so may gather at the top or the bottom of the vessel. When an accurate concentration measurement for a known contaminant can't be made, or if an unknown contaminant is suspected, play it safe. Wear a respirator. In addition to the 3 atmospheric checks we have just discussed, all confined spaces or other work areas where there is a possibility of heat stress should be tested prior to and during work using a wet bulb globe thermometer. This is an instrument that measures the combined effect of temperature and humidity to warn of heat stress danger to humans. An attendant or observer is required at all entrances to a permit entry space, depending on the degree of hazard. In some low-risk situations, the person signing the permit may authorize an unaccompanied entry by a qualified worker. However, all pre-entry atmospheric checks must be within acceptable limits, and the worker must wear a portable monitor during the entire time he is in the space to warn him of any changes in atmospheric conditions. When an attendant is required, he must remain on station while employees are within the confined space and can have no other duties that conflict with his primary duties of observation and communications. There are 2 types of observers: the work monitor and the fire watch. A work monitor is an observer who watches all employees working in a confined space. He must stay in sight of the persons inside at all times. The work monitor has the proper safety equipment available and is ready to assist and remove individuals from the space in case of an emergency. The work monitor never enters the confined space himself under any circumstances, even in emergencies, unless another worker takes his place. If he is required to leave his post and has no replacement, all workers must come out of the space. A fire watch is an observer who stands watch during periods of hot work for fires and other possible sources of ignition. He must be ready to extinguish any sparks and flames with a portable fire extinguisher or hose if a fire starts. The fire watch should stay at his post for at least 1/2 hour after completion of hot work, which means that plans must be made to replace him during lunch and coffee breaks. It is important to have good communications between employees in a permit entry space and the attendant or observer. Sometimes natural voice communications won't work because of noise, distance, the use of personal protective equipment, or other conditions. In these cases, other acceptable forms of communication range from simple hand, rope, or light signals to electronic devices such as radio or video. The observer should also have a means of outside communication, such as a whistle or telephone, so he can call for additional help if necessary. Be sure that the attendant has all the necessary phone numbers for emergency situations. Federal regulations require a written plan of action that outlines procedures for rescuing workers from a permit entry space and transferring them to a medical facility. For extremely hazardous situations, a fully trained on-site rescue team must be standing by to provide immediate assistance to workers in case of emergency. Depending on the degree of hazard, it may be permissible to use an off-premise licensed emergency medical team, such as a local paramedic team, as long as its members are capable of performing a rescue from the permit entry space. Except for the requirement to use personal protective equipment, firefighting and rescue teams entering a confined space during an actual emergency do not have to abide by the provisions of the entry permit. The permit form should have a place to list all safety equipment required for each job. There are two categories of safety equipment: personal protective equipment and area safety equipment. Personal protective equipment includes all items of safety equipment worn by the worker. This equipment may vary depending on the type of work and the physical or chemical hazards in the confined space. Area safety equipment includes all devices for escape, retrieval, or worker support. Workers entering hazardous confined spaces must wear a body belt or a full body harness. The body belt or harness is then attached to a lifeline secured outside the entrance. Where entry is through a top opening, a tripod or man hoist must be available to lift the employee out of the space if necessary. If an entrance or exit has a drop or climb of more than 3 feet, a ladder must be available. Be sure that a self-contained breathing apparatus or other approved air source is available for emergency rescue operations. Also, when working on a vessel containing agitator blades or other mechanical dangers, a fall protection device is recommended. In this example, the worker installs a work platform or surfboard that will prevent him from slipping and falling onto the agitator blades during the work. Once the platform is secure, he moves his anchor point so he may do his work safely and securely. If you work in confined spaces or other hazardous areas, don't ever believe that safety equipment replaces the need for safety consciousness. No amount of equipment can substitute for safe work practices, such as adequate ventilation or proper testing. Safety doesn't just happen. It is the result of knowledge and responsible action. Knowledge means being aware of potential hazards and understanding how to avoid them. But knowledge alone is useless if you don't take responsible action to do what you know is right. Safety is the personal responsibility of every worker. Don't be a passive employee. After all, it's your life, isn't it?